Hello students, welcome back to this new session on mathematics for the third semester students for the subject 18mat31. I am your mathematics teacher from AITM Bhatkal. In this session, I'll be continuing the previous topic, that is finding the Laplace transform of the defined function given to you. Okay. Here I have come with one problem. Look at this. Obtain the Laplace transform of the function f of t is equal to cos of t minus 2 pi by 3 when t is greater than 2 pi by 3, and it is 0 when t is in between 0 to 2 pi by 3. Now, as per the definition, let's start the solution as, by the definition, the Laplace transform of f of t, that is L of f of t, is defined to be integration from 0 to infinity e to power minus st f of t dt. Okay. Now, your function is defined in two different ways in this complete interval from 0 to infinity, right? So, according to that definition, we will split this integral. Okay. So, this is equal to integration from 0 to 2 pi by 3. Look at that. It is given in the next part of the definition. Here, look at this. From 0 to 2 pi by 3, it is defined to be 0. So, e to the power minus st, 0, because f of t is 0 in that interval, dt, plus under integral sign. Now, the upper limit was 2 pi by 3 here. So, 2 pi by 3 to infinity. So, in this interval, when t is greater than 2 pi by 3, it is nothing but 2 pi by 3 less than t less than infinity. This interval is this. Okay. So, in this interval, the function is defined to be this. It is e to power minus st as it is. The function f of t is defined to be cos of t minus 2 pi by 3 into dt. Now, as usual, 0 into e to power minus st is 0, and the definite integral of 0 is 0. So, this part turns 0. We did not do anything over here. Only we have to evaluate the second integral. So, that is integration from 2 pi by 3 to infinity e to the power minus st cos of t minus 2 pi by 3 dt. Now, to evaluate this, I will use the formula. I suppose you remember that formula. I had given it in a number of times in my class, but still I will write it in corner like this. So, what is integration of e to the power ax cos bx dx? So, use this formula here. Now, as per the formula, it is integration, e to the power ax divided by a square plus b square into a cos bx plus b sin bx. So, in this case, I will be using this formula to evaluate this. Okay. Now, as you see, a and b are the coefficients of x over here, right? Here also we are integrating with respect to t. So, we need to look for the coefficients of t in both of these functions. So, the value for a is minus s, the value for b is 1. Okay. So, a is minus s, b is 1. So, using these values, let us write directly the solution for this integral using this formula. So, this is equal to I will take a bracket because we are writing the direct solution using the formula. It is e to the power minus st, because you write e to the power ax over here. So, it will be e to the power minus st divided by a square, means it is minus s whole square, which is s square, plus 1 square, which is 1, in the bracket, small bracket. Yes. Value for a is minus s. So, minus s, the first function, that is cos of t minus 2 pi by 3, plus value for b, it is 1, sine of t minus 2 pi by 3. This from the limits t going from 2 pi by 3 to infinity. So, we have to substitute for t going from 2 pi by 3 to infinity. I hope it is clear up till here. Just we are substituting the formula. Now, we have to put the upper and lower limits. So, this is equal to, yes. Now, when you substitute the upper limit as infinity, you forget about this bracket, the inner bracket here, which I have written. Okay, let me give a complete simple bracket. Okay, so this bracket you just leave. No matter what it takes the value. Look at this, what happens here. E to the power minus s t. T you are substituting infinity. So, e to the power minus s into infinity it becomes. It is something like this. E to the power minus s into infinity, which is e to the power minus infinity. And you all know what is e to the power minus infinity. It is 0. Means no matter what is this bracket, e to the power minus infinity into this bracket turns 0. Because 0 into anything is 0. So the upper limit is 0 here. Minus the lower limit. Now I have to put t as 2 pi by 3. So it becomes e to the power minus s into 2 pi by 3 divided by s square plus 1 as it is in the denominator. Now let us substitute t as 2 pi by 3 in the inner bracket. So it is minus s cos of t is 2 pi by 3. 2 pi by 3 minus 2 pi by 3, which is cos 0 plus 1 into sine, it is sine 0 here. Okay, because t minus again 2 pi by 3 and t is taking 2 pi by 3 here. This is your lower limit. Complete the square bracket. Now this is equal to, now however there is minus sign here, so keep that minus sign as it is, minus 2s pi by 3 divided by s square plus 1 over here, and cos 0 is 1, sin 0 is 0, so this becomes minus s into 1, which is 1. This is already 0. You can just take a simple bracket like this, or you can further simplify this as, I'll just take it little up. I hope it is seen there. Okay. So now this is plus e to the power s into e to the power minus 2s pi divided by 3 over s square plus 1. This is the complete solution for this problem. I hope it is clear to you. I'll give one more problem on this. Okay, try out this at home. Okay, on your own. Look at this. Example 3 on this. So here is one problem for you as homework. Find the Laplace transform of f of t is equal to sin 2t when t is in the interval 0 to pi and it is 0 otherwise. Okay, so you can just work for this problem. It's very simple, and if you have any doubt in this problem to work, okay, you can ask me in our WhatsApp group. I'll come up with some more videos on some more interesting problems on Laplace transform. Okay, if you have any doubt, please do ask me. Continue in my next session. Thank you.